accepted.
I would like to start with a very unexpected intro that will make you wonder, am I in the right talk? Is it a history class? Please bear with me, and let's jump straight into the 19th century, where Ada Lovelace, the first programmer ever, is sending a pull request to Charles Babbage, the inventor of the first general computer. I'm half beside myself with hurry and work. I could not get anything done in time to send by coach this morning, and now I'm obliged still to retain one sheet, which, however, I hope to send you by on occasion tomorrow afternoon. I'm extremely busy. The PR will be ready tomorrow. Note B, this is the actual code, has plagued me to death, although I have made but little alteration in it. Such alterations as there are, however, happen to have been very tiresome and to have demanded minute consideration and very nice adjustments, which basically means changes are tiny, but far from trivial. It is a very, very excellent code. Seriously, this PR is gonna be epic. Rocket emoji. But then the story takes a nice twist, because Ada starts commenting on Charles himself. I wish you were as accurate and as much to be relied on as I am myself. Well, that's some really badass shade throwing from 19th century, and I see some of you may consider using this in your pull request on Monday. Please don't. You are only allowed to say that when you are all the programmers in the world. And in the 19th century, Ada was all the programmers in the world. By the way, I hope you do not take upon yourself to alter any of my corrections. I must beg you not. They all have some very sufficient reason. And you have made a pretty mess and confusion in one or two places where you have ventured in my manuscripts to insert or alter a phrase or word and have utterly muddled the sense. Which basically means, stay out of my shit, Charles. So yeah, that is GitHub 1843. That's 19th century GitHub with pull requests wrapped into manuscripts, traveling by horses between remote first programmers before remote was a thing. And this is probably the very first merge conflict after a very, very long-lived feature branch. And this story confirms my long-held belief that people who like each other, they do pair programming. But people who don't, they just do code reviews. Good morning, everyone. My name is Mateusz. I've got Twitter, I've got GitHub, and I've got a job. And this talk is put a flag on it, Busy Developer's Guide to Feature Toggles. Today I want to teach you three things I've learned while working on open source feature toggle platform Unleash. First and foremost, why we need feature toggles and why sometimes we actually don't need them. Then I'm going to help you choose different toggle types depending on the problem that you're solving. And finally, I want to show you how to manage feature toggles at scale. But let's start with a case for feature toggles. And I want you to meet Charles. This is 21st century Charles Babbage, named after the 19th century Charles Babbage. And let's create his UX persona. So Charles is a full-stack developer who works and who was raised in a post-GitHub world. So basically, GitHub existed throughout his entire career. Does it actually sound like some of you? I want to have a quick poll. Do we have any people from the post-GitHub generation in the audience? Anyone from the post-GitHub generation? Any people from the pre-GitHub generation? Yay. OK, so what does it mean in practice? In practice, it means that branches and pull requests are his bread and butter. Okay, this is how he works. And he also likes to move fast and break things. And that's actually the main reason why he became a software developer after a very, very unsuccessful career as a FedEx driver. So Charles works for a company called Conduit. And they are building this blogging platform. And this sprint, they are adding this article tagging feature. And because Charles is classically trained in GitHub flow, he obviously starts with a branch. And he hopes to keep this branch very, very short-lived. Why short-lived? Because last week, he was watching this Dave Farley show on YouTube, and he learned that continuous integration is actually much more often than most people think, and that you should actually merge your code to the main branch at least once per day. And if there is at least one person on your team who stays behind on a given day and doesn't commit to the main branch, then by this definition, you are not doing continuous integration. So he wants to keep it very, very short-lived. Now, there comes the next assumption. I'm going to make a few commits, maybe a few hundred lines of code, and it shouldn't take more than 3 hours, 3-4 hours according to Charles. Just remember, don't tell your Scrum Master that you're estimating in hours, because the Scrum Master may get a heart attack. And then he makes the next assumption. The lightning-fast build will pick up all the changes, and it will turn green in seconds. And finally, one of his buddies will throw all the work that he's been doing just to jump onto Charles's PR and just congratulate him on the excellent work that he has done. But here comes the reality check. So first, instead of coding, Charles had to entertain his Scrum Master in this 1-hour game of planning poker. Then, he had to entertain his manager in a weekly one-on-one. And finally, a newly hired intern was begging for the approval of this very, very unholy PR. So, Charles decided to postpone his PR until the next morning. And it looks like the bar that we set for CI in the 90s was still too high 30 years later. But in the morning, Charles had one of those oh crap moments. He actually forgot that when he clicks on a tag, he should open the listing of all the articles with the tag. And it's very similar to the existing global feed and personalized feed, so he started doing a refactoring. But now, instead of 5 commits, he had to make 25. Instead of 200 lines of code, it was 2,000 lines of code. But that's not the end of the story. Because then he realized that the build times got really, really slow. Because programmers never run them locally. And they never felt the pain. And GitHub Actions were more than happy to accumulate the craft, 1 second at a time, in the background, asynchronously, because nobody is watching. And finally, instead of very quick approval, Charles ended up in a comment dance with the reviewers. The reviewers left some really, really harsh feedback. But Charles promptly resolved all the suggestions. But then he had to resolve a merge conflict, because he lost a commit race with the guy who was 5 minutes earlier from lunch. But when he was absolutely ready to merge, everything solved, all those reviewers suddenly disappeared. So Charles kept waiting and waiting. But then on the 7th day, Charles ended his work, only 2 days after the demo. But still, rocket emoji to celebrate. Well, not so fast. Because next week there's a deployment. And the change that he was making put production on fire. Now, all senior developers jumped on it. They found the issue. They're cutting a hotfix branch to mitigate this problem. But now our GitHub repository looks like Guitar Hero Lever Hard. I don't know if you recognize this song. This is Slayer's Raining Blood. Or maybe it's Welcome to the Jungle, which is a nice metaphor for this code. So the question is, can we do better than those first programmers in 1843 with their long-lived feature branches and merge conflicts? Well, if I'm asking this question, then probably we can. And Ada Lovelace to the rescue. You can try inside-out development. So imagine a project that all of us would like to work on, but only some conference speakers do, as we are busy making another CRUD. So in other words, imagine one of those DDD, complex domain logic kind of project. You can start by implementing the domain logic, the business rules, the money-making if statements, or the money-breaking if statements if you got them wrong. Create a tiny PR, merge it, go to production. People can't see anything yet. It's just a domain logic, maybe some aggregate. Then you go and create your application logic, the actual workflow. Maybe you add some in-memory repository to get a unit of behavior tested. You create a tiny PR, you merge it, you go to production. People still can't see anything. So you continue, you implement your persistence logic. And here you can pick like active record, ORM, or you can just be nice to people and use a type-safe query builder, create a tiny PR, merge it, go to production. And only at the very end, you create this tiny 5 lines of code in your controller where you actually expose this thing to the end users. Okay, unless you skip the previous steps, and now you have your HTTP request high-fiving a database query, but that's not the case here. So you create a tiny PR, merge it, and go to production. And only now, people can see it. But here's the thing. Sometimes we cannot stay in our programming basement for a month and then reveal the fully polished solution to the world. And maybe we need some feature toggles. So here's our next requirement. The non-coders in our company, they want to see a walking skeleton of the application in some pre-production environment. Okay, so show us what you're building. We don't want to wait for a month. But at the same time, Charles wants to deploy his code to production continuously to avoid this needle in a haystack problem that we've seen before. And we're going to implement the same feature again. By the way, let me ask a question. How many people are familiar with the walking skeleton, concept of a walking skeleton? Okay, actually very few people. So walking skeleton is actually a tiny end-to-end implementation, for example, of tag display, that's linking the main architectural building blocks. So possibly we're going to have some controller, maybe some in-memory repository, like a half-baked implementation. Really, really poor UI. It doesn't have any muscles yet. It's just a skeleton after all, but it can walk. So how can we get this skeleton into some pre-production shared environment, maybe staging, but not into production? Well, we need to ask Beyoncé. If you liked it, then you should put a flag on it. By the way, sorry, Google, for stealing your testing line. So Conduit, the company we're talking about here, is an early-stage startup. Okay, so they use some platform as a service because they cannot afford to get PhD in Kubernetes. And obviously, because they use Heroku, they need to follow this 12-factor approach. So basically, all the configuration that they have is externalized as those environment variables. So now what we're going to do, we're going to turn the flag on as environment variable in our development environment or staging. We're going to say article tags true, but we're going to say it's false in production. And now Charles goes and writes this piece of code to read the environment variable as high up the stack as possible. So this is some backend route hidden in the if statement. Excuse my JavaScript, by the way. I use it as a DSL, as a lingua franca that hopefully everyone understands. And if I was in a room full of JavaScript developers, it would start getting really nervous here, because blood is boiling, the guy used double equals. But that's not actually the problem that's found in the code review, because the reviewer starts complaining about those environment variables spreading across the code base. And he suggests this code instead. Well, Charles assumes the reviewer knows more about programming than him, because the reviewer is using something different than Visual Studio Code. And he's actually paying for his IDE like 20 euro per month. So he must be credible. But he also likes this new abstraction that the reviewer suggested of the toggle client, because now we can actually hide where we read that toggle from. So it's a really, really nice abstraction. But then Charles continues, and he updates the UI code in React. This is like a React hook that behind the scenes will fetch the flag from the backend code. And you may ask, why is it React? Well, our parents didn't get fired for choosing IBM. We don't get fired for choosing React. Right? Maybe we should, I don't know. So, the next requirement, we need to release, this time, a dancing skeleton to our internal users in production. Now, the question is, what's the difference between walking skeleton and dancing skeleton? Well, you can only dance in production, with real logging, real monitoring, real users. And very often, we have our skeletons dancing beautifully in staging. But when we put it in production, the hand falls off. So, in theory, staging and production are the same. But in practice, they are not. Does anyone know who said this? That was Albert Einstein. At least maybe, I don't know. So, even if your ops people are telling you, hey, staging and production are the same, I wouldn't trust. So let's make our skeleton dancing in production, but only for the development team, shall we? You will need a dynamic release toggle with the user ID activation strategy. And then, as always, Countess Lovelace is like very, very careful with words. So she talks about release toggles. Probably there are other toggle types. Then she talks about dynamic toggles. So this is unlike the static environment variables we've seen before. And finally, she talks about activation strategies. So let's unpack those words. Let's start with the release toggle. And we're gonna check the feature toggles article from Martin Fowler's website, written by Pete Hodgson, who says, release toggles allow incomplete and untested code paths to be shipped to production as hidden code which may never be turned on. So it really shifts the bar from, oh, it has to work perfectly before I ship, to it doesn't break production. Woo, pressure off. Now, the activation strategy. So this is actually part of our own domain in Unleash. We call it activation strategy. And it specifies which users we want to enable the feature for. And here we're saying, in production, we're gonna enable this feature for our 2-pizza team. And those are the IDs of the users in our 2-pizza team. But then, in development, we want to have this standard activation strategy where the feature is on for everyone. So one of them is like a scalpel. The other one is like a chainsaw. Now, Charles looks at this mockup and he's like, yeah, I can build it. I can build it in a week because it seems like a really, really fun distraction at work. And Charles is like most developers who I know who prefer to build everything except from the monolith that they are paid to maintain. So he obviously starts with the mother of all software architectures, the square, square, barrel pattern. And in the middle square, there's a toggle API talking to a toggle database. And we're gonna choose boring Postgres for a database. Oh, by the way, this is full stack architecture, so we need another rectangle. We're gonna call this one admin UI to configure the toggles. And we're gonna choose boring React. Okay, but it's only half the square size because obviously the backend architecture is more important. And finally, we're gonna have a tiny SDK that we can embed inside our monolithic server-side application. And this tiny SDK will be fetching all the toggle configuration over some boring protocol, let's say HTTP. So boring Postgres, boring React, boring HTTP. Okay? Boring is good. Okay? Boring makes you money. Boring doesn't wake you up at night. So, in the meantime, the feature is ready. The skeleton got some muscles. It's alive. It's kicking. Time to show it to real users, precisely to 1% of them. And 1% sounds like a new activation strategy that we're gonna call a gradual rollout. Okay? And the important part is that each person in this, for example, 1% group should get the same version of software consistently. So going back to our configuration, now our production configuration activation strategy is the list of original 5 users we had and maybe 2 new people we grabbed from the Silicon Valley layoffs because now finally we can afford them, but also the 1% of the general user base with the stickiness. And let's stop for a second and let's think what we have just achieved. Because we have just decoupled deployment from release. So deployment is this very, very technical event where I'm getting my code from my machine to production continuously. Okay, something that was very, very uncommon in the 19th century, but unfortunately it's still very uncommon in the 21st century. But this one is supposed to be boring. Okay, let me ask you a question. Who is clapping on a Ryanair flight? Anyone clapping on a Ryanair flight when you're landing? There's always someone clapping. You are probably the same people who are clapping on a code deployment. Okay, but here's my advice, no clapping. Okay? Those are supposed to be boring, routine events. On the other side, release. Ooh, that's a different story. It's a very, very exciting business event because now we're showing new capabilities to the world. and we can be selective about it. So we should celebrate, drink some champagne, but not too much because there's another day and another requirement. And this time our product manager is very eager to release this feature to the entire user base. So she's like, we need to move fast. But here's the thing. Sam, our new head of operations at Conduit, he wants to keep an eye on performance. He's like, okay, you can move fast, but please do not break things. And there's a reason why he says so, because Sam recently left a Ruby shop, and he tells this story. DevOps don't know. Prod is getting hot. At the Ruby shop, doing something unholy. So, Conduit is not a Ruby shop, but still, the performance implications of this new SQL query that we're introducing are unknown at a bigger scale. So we want to have an option to turn it off, just in case this query starts doing something unholy. So let's create a new toggle type. This time it's going to be operational toggle to communicate what we're doing. We're controlling the operational characteristics of our software. And the difference is actually mostly in semantics. And you know what? This time, this release was a huge success. So devs are sold on feature toggles. Ops people are sold on feature toggles. They are dancing. They're happy DevOps dance. But now the marketing dude, he wants to join the party. He's like, woo, big dollar, huge dollar, big potential. And he wants to measure which of those two variants generates more clicks. Is it popular tags or is it trending tags? And test it in production. So let's create a new toggle type. This one will be an experiment toggle. We're going to call this one article tags title. And by the way, do not try to recycle the previous feature toggle. Because if you recycle feature toggles, then those things happen. Please do not turn off the light switch. It also operates the elevator. So obviously, there is a toggle in the lighting subdomain that also operates the transportation subdomain. Okay, that's some really, really surprising coupling. Going back to our experiment, we're going to say we want to run this experiment on 100% of our user base, but now we also need a variant. Okay, one variant will be, okay, one group of people, 50%, will see title A, popular tags. The other group will see trending tags. And now we want our marketing folks to actually control the text that will be displayed. And maybe we even allow them to inject some CSV or JSON. So it almost feels like programming to our marketing folks. But to make this magic work, in addition to this simple is the flag on or off, we also need to support get variants to get those data injection attacks from marketing. But there is actually one more thing that will make our feature toggle solution really, really joyful to use. And it has to follow so-called Unix philosophy. Okay, so it should do one thing very, very well. So surprise, surprise, your feature toggling solutions should be really good at feature toggling strategies, but also it should play well with others. So it shouldn't pretend that it's great at everything. So for example, it should be very, very easy to integrate with whatever existing analytics solution you have. So for example, emit some kind of an event on flag resolution. And probably your company already has an opinion which analytics solution you like to use. And possibly you already have more than one. And you don't want the feature toggling solution to be another spy on this list. Let's talk about the next problem. Our blogging platform also supports a comment system that was built a long time ago, and it's not very stable. When too many people start commenting, the entire website goes down. And just to give you a backstory, this is Michael. This is the developer who built it. This is a senior developer who built it. And because CI server was constantly failing for him, he just disabled everything. He was, I'm going to disable types in TypeScript, and now we have suggestion script. He was like, linter can't tell me what code to write. And now the code base looks like this is Sparta meets modern functional programming wonderland. So now you have like while loops and for loops, but then suddenly you have a flat map that Michael didn't really understand. So he copied code from Stack Overflow. Unfortunately, he didn't copy the code from the most upvoted answer. He didn't even copy the code from the least upvoted answer. He actually copied the code from the question itself. And then he left. But before he left, the manager asked him, hey, can you document your shenanigans? Can you write some ADR? And he was like, no, I'm just going to write this comment. This is not a bug. This is just the way we do things. Which doesn't actually bring much confidence. But now, before we fix our code, we need a way to disable those comments just to mitigate potential incidents. And we need a toggle for this, a very specialized toggle that we know as a kill switch. A kill switch, disable comments kill switch. It's almost the same as the operational toggle, but usually this one lives much longer. And you can think of a kill switch as the inverted feature flag. So by default, this toggle is off most of the time. You turn it on, and you kill the feature. But here's the thing. Very often, our ops people, they don't want to just click something in the UI, but they want to integrate this kill switch with their monitoring infrastructure. So they will need to write some scripts. And this is not a trivial thing to do. So we need to explain, hey, how does our API work? How do you turn the feature on and off through the API? How do you access this API as a person, but also as a machine? So in other words, your feature toggle solution needs a manual that people can read. And if you want people to read your manual, then you need to make a better manual, and it cannot be something that you always postpone into Q4. And why am I saying this? Because it looks like our super simple toggle solution, like a week-long project, is getting more and more complicated, both at the code level, but also around the code, like in the docs, for example, as it becomes part of a platform that other teams can work upon. And this is the first time that Charles thinks to himself, we do those things not because they are easy, but because we thought they were going to be easy. And then he hides. Now, let's summarize this part. We've seen the most common feature toggle types. We've seen release toggles for building new features. We've seen ops toggles for controlling the rollout, the performance characteristics of a rollout, for example. We've seen experiment toggles for A/B testing, and we've seen kill switch toggles for mitigating incidents. But honestly, there's actually many more jobs to be done for feature toggles. And let me ask you a question. How many people are familiar with jobs to be done theory, JTBD? Very few people. So basically, people hire your product to do different jobs. So this lady in the pink, she's hiring this frying pan for experimentation purposes in her kitchen. But the other lady, well, she's hiring this as a kill switch to pacify her partner who didn't buy her tickets for this lovely Devoxx conference. Jokes aside, last part. Let's talk about feature toggles at scale. Because here's the thing, as companies adopt feature toggles, they start creating more and more of them. And very often, toggles become the victim of their own success. And this is actually what happened at Conduit. The dev team has to type the same 5 user IDs over and over again. So obviously, there's like a missing abstraction. And I'll tell you, like most feature toggle solutions eventually come up with something that they call a segment. Okay, so we're going to create a segment called Conduit Dev Team. And we're going to say those 5 users with those IDs working on the application called Conduit, this is our segment. Okay, and now, instead of typing the same stuff over and over again, you just use a segment. And next time someone leaves your team or joins your team, you don't have to update like 30 different toggles. You just update the segment. But here's the important part, and this is probably the most important part, is the data that you use to evaluate your toggles. It should never, ever leave your SDK client, and it should be always evaluated locally. Why? Well, first, because it's much faster. Okay, if you can evaluate everything in memory, it's much faster. You don't have to send any data over the wire. You just fetch the toggle configuration once, and then you evaluate it locally. But also, and it's even more important, for data privacy reasons. And I see some of you don't mind, for example, sharing your heartbeat with Apple or Google, as I see all those cool smartwatches. But personally, I would be very concerned if my banking application, for example, was sending my personal data to evaluate the toggle to some third-party provider. Okay, let's talk about the next problem. Some of the users start complaining. I'm getting this password is too common. What does it mean? Well, it turns out the development team was working on these new experimental password hint features, but someone accidentally turned it on. So we have a toggle, so let's turn it off quickly, and let's do a post-mortem. So first, we need to find the impact of this change. How many people have seen this toggle? Well, it's only 3%, so it's not that bad. But now, we can actually go to the crime scene, to the actual event log, and to see who did what and when. And check this out. This is Alex. This is our sales guy who was so eager to demo this feature to a customer that he actually turned this feature on during customer call as he was demoing stuff, but he also turned it on for everyone else. Now, obviously, Alex feels really, really sorry for his mistake. But we need to do something with Alex. This is the second time it happened this month. Should we punish him? No, because we can solve this problem with an API. And I would argue we can solve most of the problems with an API. We need an API for this. We need to assume positive intent. Okay? It's not his fault. It's a systemic problem. Why did our system of work allow for this type of mistake? How can we prevent people from different parts of your organization from making those mistakes and flipping the toggles for the other team? So what do we need to do? We need to organize our toggles into projects. Then we need to assign people to those projects, and we need to give them permissions. So Alex becomes like the sales team's team member, and he can only touch his own toggles. And here's actually a big lesson I've learned over the years, is that your feature toggle organization, the way you organize your toggles, will be only as good as your organization. So this is going to be another manifestation of the Conway's law. So just to give you an example, if you have some post-technical VP of engineering who's detached from the reality by like 20 years, and he or she is drawing happily some organizational structure in PowerPoint, then you probably have a problem. But when you have a VP of engineering who deeply understands like team topologies and bounded context, then you are probably in a good spot. All right, last challenge of today. Conduit got 100 feature toggles in their system. And Charles is really, really annoyed. He's like, toggles suck. I'm going back to long-lived feature branches. Well, it's your usage of feature toggles that sucks, Charles, because let's get it straight. Long-lived feature branches are a problem, but so are long-lived feature toggles. Most of them should not live forever. And our recommendation at Unleash is that your operational toggles, those controlling the performance rollout characteristics, for example, they should probably last for a few days. The release and experiment toggles, probably for a month, so that you can roll out your feature or finish the experiment. And the only exception to the no long-lived feature toggles rule is the kill switch toggle that I personally recommend to put in a separate project. And now, your feature toggle platform should give you insight. Which of your toggles are getting expired? Which of your toggles are getting stale? And tell you when the health of your toggle ecosystem is being neglected. And remember, removing one stale feature toggle a day will keep a doctor away. Or I should say, will keep a vet away, because there's really one thing that your dog and feature toggles have in common. You should clean after them, okay? Please clean after your toggles. And if you see your neighbor not cleaning after their toggles, please let them know. And if your own feature toggle is getting stale and it stinks and nobody's watching, you still need to pick it up. So for example, the new billing system experiment. This flag hasn't been seen in production for like 3 weeks. It means someone probably already removed it from the code. Well, we can probably also archive it from our toggle database. And here's the thing. When people see those more advanced enterprise-y kind of capabilities, they start realizing the complexity of the problem. And don't get me wrong, there is value in building this type of stuff yourself. And many companies can afford it, like GitHub can afford it, LinkedIn can afford it. And I'm pretty sure what they build in-house is really fit for purpose and really, really joyful to use. Unfortunately, most of the feature toggle solutions I've seen built in-house usually look more like this. There's like a million unrelated switches. You have no clue what most of them are doing. And when you attempt to refactor this mess, there is always this senior family member who holds this solution as the ultimate symbol of power. And he's like, this is mine, don't touch it. So what can you do? You just learn to ignore most of the other feature toggles. You create your simple 10 feature toggles for your team, for your application. You give them meaningful name, and you just hope that you never ever click the red toggle just above your toggles. Who knows what it's doing? Going back to the eternal question, should I build this stuff or should I buy it? Well, domain-driven design literature gives us a really, really nice tool for categorizing different parts of our domain so that you don't fall into this trap of, oh, I need to build everything myself because I'm so great at software, or we need to outsource everything because we are so rubbish at software. So you should be somewhere in the middle. So core subdomain, this is actually where you make most of your money. This is where you want to put your most expensive people. And I really, really hope that's you. On the other hand, you have supporting subdomain. This is all the software that you build in-house to run your business, but that's not your differentiator. So you can put less expensive people here. So hopefully that's not you. Hopefully that's the person sitting next to you. And finally, you have this generic subdomain. This is all the open source. This is all the software as a service that you can grab off the shelf to solve those generic problems. And very often, companies start with their own in-house feature toggle solution, and they realize, you know what? No customer gave us 5 stars on App Store because of the custom feature toggling solution that we built. So to minimize the cost, they reach out for the off-the-shelf solution. But some other times, people decide, you know what? I'm going to build best-in-class solution for something that everyone else was doing in-house. And maybe I'm going to turn it into an open source project, or maybe a business, or maybe both. And this is what happened to my colleague Ivar, who started Unleash like 10 years ago as a side project at work. And over time, it has become like extremely popular. There's like 18 million Docker downloads. There's SDKs for all major languages. And now the GitHub stars are pouring. So probably my GitHub stars are no longer up to date. And now other companies start building on top of it. So for example, as GitLab does, they actually build their own feature toggle solution on top of Unleash. So here's the thing. With open source, it's not really build versus buy, because first you can buy in quotation marks, because if it's open source, you can just take it and start building on top. So let's summarize. First and foremost, remember to separate exciting from boring. Deployment boring, release exciting. I encourage you to explore different jobs that you can hire the feature toggles for, and we only scratched the surface here. Remember to clean after your toggles the same way you would clean after your dog. And finally, be aware of the costs of building this type of stuff yourself. And it's almost the end of my story about development with flags, and I was thinking about some nice, memorable shortcut, like maybe BDD, like be on site-driven development. But this one is probably taken, right? There's only so much acronym real estate in software development. So let's try this one and see if it sticks. FFDD, feature flag-driven development. Let's try this. And before we go, let's actually check what's up with Charles, because he's been promoted to a senior developer. He's a senior developer now, and GitHub is here to stay. And actually, it's so popular that some tech bros even mistook GitHub for a hiring tool, and they think it's a resume. No, it's not. But now, Charles starts questioning branches and pull requests for some types of work. Maybe if I'm changing a color of a button, maybe I don't need a pull request for this. And finally, because he started using feature flags, now he can really move fast. And actually, he hasn't broken anything for a while. And because of this, last week, he found this very old-school physical letter in his very old-school physical mailbox. And it reads like this: Dear Charles, you are finally as accurate and as much to be relied on as I am myself. Okay, thanks, bye. Ada. Thank you.